video on multi-step algebra equations with polynomials. We're going to do equations where the variables are on both sides. Right? So for example, if I gave you 2x plus 2 equals 3x minus 8, for example, we have variables on both sides. So it's multiple steps. So let's check this out. Let's do this one. Come right into it. So it doesn't matter which one you get rid of first. You can get rid of the variables with the coefficient, or you can get rid of the numbers. It doesn't matter. Normally, some people try to get rid of the smaller number, the one with the smallest absolute value, or the least absolute value. So it doesn't matter. So, for example, I can get rid of the 2, right? Whatever you do to one side, you have to do to the other. We'll bring this down now. So now I'm left with 2x equals 3x minus 10. So minus 8 minus 10. Minus 8 minus 2 is minus 10, right? So now, you don't want to get rid of the 2x, because that'll give you a 0. You don't want a 0. So you get rid of the 3x. And again, whatever you do to one side, you do to the other. So here we're going to have a negative x is going to equal negative 10. So if we wanted to find what x was, well, we do the opposite. If negative x equals negative 10, then positive x equals 10. So we can check to see if we're right. So we're saying now that x is 10. And we'll just bring it up here. We'll bring it way up here. There we go. X equals 10. Now let's plug in x to see if we're right. So let's write this over. Okay, so I'll bring it over here. So we're saying now that the x is 10. Remember, the x was here. Remember, this was 2x plus 2. Now it's 2 times 10 plus 2. So this is going to be 22. And if we don't get 22 over here, then it's not correct. So 3 times 10 is 30. And 30 minus 8 is 22. So they're equal, even though the 2's aren't exactly the same. But there we go. All right. Let's do a few more. So what if I gave you this? So if I said negative 3 x plus 2 plus 5 equals negative 4 x plus 5 minus 10. So we have a lot of things going on here. We have variables on both sides. First thing we should do is try to combine like terms. And we did this in previous videos. We need to distribute. We need to distribute this and then distribute that. So let's do that. Let's bring this up. So we're going to have a negative 3x minus 6 plus 5, right? And a negative 4x minus 20 minus 10. And you can combine right here, negative 6 plus 5. What's negative 6 plus 5? It's negative 1. So we're going to have negative 3x minus 1. It's going to equal negative 4x minus 30. Where'd that come from? Minus 10, minus 20, minus 10. Negative 20 minus 10 is negative 30. Now, let's combine. Let's move things around. It doesn't matter if you get rid of the negative 1 or you can get rid of the negative 30. It doesn't matter. Whatever one you want to do. So let's do this over here. Clean this up a little bit. We'll bring that up so we can see more. There we go. That's where we are right now. And if it wants to stay up, it doesn't want to do that today. Oh, there we go. Okay. So let's get rid of the negative 1 by doing plus 1. And whatever you do to one side, you have to do to the other. Right? So this will give us negative 3x, because this is gone now, right? Equals negative 4x minus 29. Now, which one should we get rid of? You only have one choice. That one. Because if you get rid of this, you're left with 0. So we're going to add the 4x on both sides. Add the 4x on both sides. And then we're going to have x, there's our x, equals negative 29. Now let's see if it was correct. So I'll bring this up and we'll write the original equation, but we'll put in negative 29 for x. So we're saying it was negative 3. There we go, see it? Negative 3. And then it was negative 29 plus 2 plus 5. Let's just do that one first. Get this out of the way. So negative 29 plus 2, we can get rid of that also. This is going to be negative 27 plus 5. All right, we're going to have positive 81. Negative and a negative is a positive. Positive 81 plus 5, that gives us 86. So we have 86 on one side. We have to get 86 on the other. So we'll just write 86 over here. That's what we're trying to get on both sides. Well, let's look on the other side. What did we got on the other side? Let's clean this up. On the other side, we said it was negative 4, negative 29 plus 5, minus 10. So here we're going to have negative 4, and negative 29 plus 5 is negative 24. Now what do you do? So this is going to be 96 minus 10, and we get 86. There we go. It equaled out. Well, let's look at another one. Erase this. So let's do a word problem. How about a word problem right here? Let's say that Bob, we'll use Bob. Bob has X amount of dollars, has X dollars. Right? Bob has X dollars. And let's say Fred, use Fred today. Fred has 5 more. Then 3 times as much. Right? So Bob has X dollars, and Fred has 5 more than 3 times as much. So let's just look at this expression first before we continue. We can make an expression. We know that Bob has X dollars, and if we want to know what Fred has, we can add Fred's. Fred's is 5 more than 3 times X. So it's 3 times X plus 5. Whatever Bob's money is, so this is Fred and this is Bob. Right? He has 5 more than 3 times. Now let's add to this. Let's say together they have $41. Together they have $41. So together, $41. There it is. You just combine like terms. 3x and x is 4x. So I'll bring this down now. We have 4x plus 5 equals 41. Just do some algebra. Minus the 5 on both sides. Right? Bring this down more. There we go. And 4x equals 36. And then we divide the 4 on both sides. Running out of room here. We can do it. And we know x equals 9. Let's see if it's right. So if Bob has $9, we can replace the x with 9. Fred has 5 more than 3 times as much, so 3 times as much would be 27. And 27 plus 5 is, right, that's 32. So we know that Fred has 32, Bob has 9, and 32 plus 9 is 41. So it worked out. Before we do that, here's your first 2 problems. Let's write these down here. Problem 1. Here's problem 2. So problem 1, solve this if I said 5x plus 2 equals negative 3x minus 5. Find x. That's your first question that you'll have to send in classwork, Google Classwork. Second question is negative 3x minus 5 equals 7x minus 10. Find x there. Okay, write that down. All right. So let's do another question, then I'll give you the third question for today. If I had 30j, use j today, why not? 30j equals 300 over j. how can we solve something like this? 300j equals 300 over j. So a question like this, you would have to multiply up. Remember, one of the rules you can do when you're doing stuff like this is you can multiply up or divide down. So you can do 300 divided by 30j, or j times 30j. So what is j times 30j? J times 30j. That's what it is, right? So it's just going to be 30j squared. 30j squared. It's going to equal 300. Now I can get rid of the 300 on both sides. Right? And then what are we left with? J squared equals what? So j squared equals 10. So let's write it up here now. We're saying j squared equals 10, but we want to find what is j. So we're going to square root both sides. You can do this. So j is going to equal the square root of 10. That's all you need to know. J is the square root of 10. What do you think the square root of 10 is? What's close to the square root of 10? It's up a little more. It's between the square root of 9, right, or the square root of what? What's the other perfect square? 16, right? So it's closest to the square root of 9, which is 3. So you can say the square root of j, you can say roughly maybe, just doing a guess, maybe it's 3.2 or 3.1, roughly. Right? And if you put it actually in the calculator will give you about 3.162, roughly around that. So it's pretty close, right? Now if you take a calculator and you plug in j for the square root of 10, right? If you said 30 times the square root of 10 in your calculator, you'll get about 94.86. So let's say 94.86, roughly. Now if you did the same thing over here, in your calculator, you did 300 divided by the square root of 10, you'll get the same thing, 94.86, roughly. That's how you can check your answer. So you should rewind the tape on this one, because this can be a little confusing. I'll do one more with that square root so you understand something. So you can always do that. That's a tool you can use. And we've done this before with the Pythagorean theorem. So if we know that, let's say, c squared equals 36, and we square root both of them, and then we're going to have c equals the square root of 36 is 6. Got a perfect square there. Sometimes you don't get a perfect square like the square root of 10. So here's the third question for you. All right, so for number 3, see if you can do this problem. Let's say I have negative 6 plus g. See why she never used 6 and g? Looks the same, right? Let's do a different one. Let's do negative 6 plus m. How's that? Negative 6 plus m equals negative 6 m minus 5. That's your third question to hand in. And your fourth one, right, by the way, there's our numbers that are missing. There they go. There's 3, there's 4. Okay, so number 4, if I gave you m squared plus 1 equals 3 over negative 12, what would m be? Try to find that answer. All right, there's 4 questions in this video. Great job.